This is lesson 7.6. You should be on page 466. This lesson is called Solving Systems of Linear Inequalities. You have to be able to do lesson 6.7 in order to do this lesson. Here's a little review of lesson 6.7. That was the lesson where you were graphing an inequality. You had to graph a line, either bold or dotted, depending on what kind of inequality you had, and then you had to test a point and shade one side of the boundary line. You have to be able to do those steps to do this lesson. A system of linear inequalities in two variables, or simply a system of inequalities, consists of two or more linear inequalities in the same variables. This is the same explanation you had at the beginning of the chapter, what a system was, but up to this point we've solved system of equations. We're going to work on system of inequalities today. Here would be an example of a system of inequalities. You can see I shaded it here in light blue. You have two inequalities. A solution of a system of inequalities is an ordered pair that is a solution to each inequality in the system. So remember, for something to be a solution, it has to satisfy every inequality or every equation in your system. For example, 6 negative 5 would be a solution of the system above. Let's check that. If I put a 6 in here and a negative 5 in for y, 6 minus negative 5 is 11, and 11 is definitely bigger than 7, so it works there. Let's try in the second equation. 2 times 6 is 12, plus y is negative 5. That equals 7. 7 is definitely less than 8. That would be true there, so this is definitely a solution. The graph of a system of linear inequalities is the graph of all solutions of the system. Now you notice they use the term graph here. The only way you can solve a system of linear inequalities is to graph. So I put this note here. You need to graph to solve these because there are infinitely many correct answers. Remember, when there's infinitely many correct answers, the only way I can really show them all is to graph them. It's impossible to write them all out. Substitution and elimination do not work on inequalities, only equations. Okay? I got to put inequalities there. So elimination, substitution does not work on inequalities, only equations. Let's keep going. So how do you graph a system of linear inequalities? It's a pretty simple two-step process. You graph each inequality just like you did in lesson 6, 7. And now here's the one thing that's a little different. You are going to graph the intersection of the half planes. The graph of the system is this intersection. So here would be an example problem in your book at the bottom of page 466. Graph this system. Well, you notice these are both in slope-intercept form, so this should be pretty basic. Inequality 1 has a y-intercept of negative 2, so I'll plot it, and a slope of negative 1, which means down 1 over 1, and you can see it's going to create this line, which remember is dotted because I have an inequality, no equal. Now let's think about the shading. Let's do the test point 0, 0. If I plug in 0 for y and 0 for x, on the left I get 0, and on the right I have negative 2. So you got to think, is 0 greater than negative 2? Is that true? And yeah, 0 is a bigger amount than negative 2 on a number line. It's farther right, so this is true, which means I should be shading above the dotted line. Now you don't actually shade yet. Just keep that in your mind. I got to shade above the dotted line. Now go to the next equation. Maybe I'll work this in blue. The y-intercept is 6, which is up here, and my slope is 3. Now I'm running out of room if I go up 3 and right 1, so let's go down 3, left 1, and I'll do down 3, left 1. I'll just go work backward. There's that line. You notice how it's bold because we have equal in the problem. Let's think about shading here. Let's try 0, 0. If I plug 0 in for y and 0 in for x, I'm going to get 0 less than 0 plus 6. That's true. 0 is less than or equal 6. I should be shading to the right of my blue line. Let me draw this in blue. So I want to shade above the bottom line and right of the blue line. Now here's the key thing. I want to shade the intersection. In other words, where do these shadings overlap? Well, if I shade above the dotted line and right of the blue line, can you see we're going to overlap the shading in this region? This is the answer to the problem. It's where the two shadings overlap. The solution region. In example one, the one I just showed you, in the book, they kind of shaded both lines, and you kind of saw a double shading at the end where we ought to be shading. It says here in the book, from this point on, only the solution region will be shaded. So we only want to shade what I did in blue in that last example we did. Okay? We're only shading the intersection of the half plane. So the proper answer to this problem would only be me shading what I did here in blue with my pencil. I do not, let me get this in red, I don't want to have this or that shaded, or here either. I don't want to shade there, only where I had in blue. Only where the half planes overlap. And that's what this is telling me. Okay, let's try a couple. I have the next two problems on graph paper. Let's try these. Okay, for this problem, the first equation, the first inequality, it's in slope-intercept form. My y-intercept's -4, and my slope is a +1, so up 1 over 1. And you notice how this is a less than, there's no equal, so let's draw a dotted line, and I'll do that right now real quick. Just trying to line this up. Okay, now let's think about my shading. 0, 0. If I plug a 0 in here and I plug a 0 in here, I get -4. Is this true? Is 0 less than -4? Not on the number line, it's not. 0's bigger, so that's false. So I'm going to make a little note for myself. I ought to be shading this direction for my dotted line, below it. Let's go to my second inequality. I'll do this one in blue. My y-intercept's 3, and my slope is -1, which is down 1 over 1, down 1 over 1, and so on. And I got to go ahead and graph this one now. Let me get out my ruler. I need a bold line, of course, because I have equals. And let me draw my bold line. Let me line this up and do it. Oops, I said bold line. Let me change that to bold. That should work now. There we go. Okay, now let's test 0, 0 on this equation. If I plug in a 0 here and I plug in a 0 here, 0 plus 3 is 3. Is this true? Is 0 bigger than 3? Not on the number line, it's not. So 0, 0 is on the wrong side, which means I should be shading up above the blue line. So now I got to combine. I wanted to shade below over here for the dotted line, but above the blue line, and when I combine those shadings together, it would be only in this region. This is the only place above the bold line in blue and below the dotted line where these two regions overlap. These are my solutions over here. Okay? Let's do another one. Let's do this one. We have 3 inequalities here. My first inequality, my y-intercept's 2, and my slope's -1, so I'll go down 1 over 1. And do you notice how in the inequality it says equal? So I'm going to go ahead and use a bold line. Okay, so let's draw a bold line through this. Just trying to line these up so it looks nice. Okay, there's that. Next, y less than 4. Well, I need a dotted line, and remember, the y values are right here at 4. Oops, I said dotted line. So dotted line here at 4. Now, I forgot to do something here on my first inequality. I better figure out which side to shade. I totally forgot about doing that. Let's try 0, 0. If I plug in a 0 here and a 0 here, I get 0 greater than equal 2. Is that true? No, 0 is not bigger than 2. So I don't want to shade below the dotted line. I'd want to shade above. I'll make a little note here. I want to shade above my bold line here. Okay, now let's go to the dotted line. I got that drawn. Let's try plugging in 0. Is this true? Is 0 less than 4? Yeah, it is. So 0, 0 is true. I should be shading below this line. I'll make a little note. And I have one more here. X less than 3. Now, if x equaled 3, I would have a dotted line right here for the less than. There's the x equals 3. There's a dotted line. And let's put in 0 and test 0, 0. Let's put it in. Is 0 less than 3? Is that true? Yeah, it is. So I want to shade left of this line. So I want to shade above the bold line, below the horizontal dotted line, and left of the vertical. Can you see how that would be in here? I'm only shading where all three of these things overlap. That would be the answer to that problem. Okay? Any of these ordered pairs in this region or on this bold line from here to here would be a solution or an ordered pair that would make all three of those systems, all three of those inequalities in the system true. Okay? They will also ask you to write a system of inequalities for a shaded region. In other words, they'll also give you the picture, and they'll want you to write the system out. Okay? So let's work on this one. Let's first of all look at, can you see how this shaded region is bordered by two borders? One here and a second here. This equation or inequality should be easy. It's a horizontal line at y equals 3, and it's the values above. So y greater than equal 3 would be inequality number 2. Inequality number 1, slope-intercept form. My y-intercept's 1, so I'll put a plus 1 for b, and my slope looks like it's up 2 over 1 each time, so my slope is 2, and I have a dotted line. That means it's either a less than or a greater than. Let's plug in 0, 0. 0, 0 shouldn't work. You notice I need to shade the left of my dotted line. That's where the shading is up here. I got to go left. So 0, 0 shouldn't work. If I put a 0 in here and a 0 in here, I get 0 and 1. What would be a false statement? 0, 0 is supposed to be false. Well, 0 bigger than 1 would be false, so I would need a greater than symbol for that. And there's my inequality, okay, or my system of inequalities for that statement. You will have word problems that will ask you to do that also, like in this question. The NCAA regulates lengths of aluminum bats used by college baseball teams. The NCAA states that the length in inches of the bat minus the weight in ounces cannot exceed 3. So if X is the length of the bat, I don't know the length, and I let Y be the weight, X minus Y cannot be bigger than 3. So it's got to be less than equal 3. So there's one inequality. Let me quickly rewrite that in slope-intercept form. So X minus Y less than equal 3, which means take away the X. Negative Y equals negative X plus 3. Less than equal. Divide everything by negative 1. Now don't forget, when you divide by negative 1, the inequality must be flipped around, and I get 1x minus 3. Okay, let me graph that. So you'll notice here, they have a scale of 5. Here's 0, 3, and their slope is up 1 over 1. You can see up 1 over 1, up 1 over 1. They're using a scale of 5 each time, but so same thing. Up 5 over 5 is the same as up 1 over 1. So there's that line. Here's the next thing. Bats can be purchased at lengths from 26 inches. So in other words, my bat length, which is X, can be greater than or equal to 26. So look at over here. 5, 10, 15, 20, 25, 26. There's my horizontal line. Misspoke. Vertical line, I meant to say. Vertical line at 26 bold. And you notice there's shading right of that. And then bats can be also up to 34 inches, so x less than equal 34. So here you can see a vertical line at 34, and I want less than that. The bat must be at least a positive weight, so y must be greater than equal 0, so I got to shade above this. And I guess one more thing I should have said, I got to test this line. If I plug in 0, 0, that's true. I ought to be shading above this. And if I combine all these together, I'm shading in this region. These are the values that would meet the conditions of the bat. Any of these ordered pairs, like for example, 10, 15, 20, 25, a 30-inch bat that weighed 5, 10, 15, 20, 25, 30, a 30-inch bat could weigh 30 ounces and be legal because 30-30 is in the shaded region according to the NCAA. Okay? I'm going to stop the video here. If you have questions, make sure you ask in class.